If x is positive, which of the following could be the correct ordering of 1 over x, 2x, and x squared? This question here is very, very tough. And the reason it's tough is because if you try to do it simply by testing numbers, which a lot of people will probably use to approach this question, even if you choose pretty smart numbers, you still may not reach the right answer. And so what do I mean by smart numbers? So you want to choose numbers that are going to give you different sorts of behavior for the numbers in our set. So when will that happen? So you might want to choose a number where x is a positive integer, so something greater than 1. You might want to see what happens when x is equal to 1. You might want to see then what happens when x is between 0 and 1, because x has to be positive, so at least we are limited there. But so if this is your only criteria, though, what will happen? So let's say we say x is 3. Then our values become 1/3, 6, and 9, and our ordering becomes 1 over x is less than 2x, which is less than x squared. And of course, that is not even an answer choice, so not anything we can do with this guy. And so then maybe if we say, okay, x is equal to 1, well, when x is equal to 1, 1 over x is going to be equal to x squared, and we don't have anything where any of our two numbers are equal to each other, so that also doesn't work. So now we're left with just fractions, which might make you think, okay, we're making progress here, because so let's see if this works. So if we say x is 1/2, 1 over x is 1 over 1/2, which is 2. 2x is going to be 2 times 1/2, which is 1. X squared is going to be 1/2 times 1/2, which is 1/4. And now what do we get? Now we get our order is x squared is less than 2x, which is less than 1 over x. And here we finally have an answer choice. This is statement 1, so anything that doesn't have a 1 in it, we can eliminate. Now, if you stop here, because if you conclude, okay, well, all values for x between 0 and 1 are likely going to have the same result, you would select the wrong choice. So you really have to select 4 or 5 numbers here to reach the right answer. And there is no great way to determine which fractions to test next, but so let's see if I test something like 9/10. Let's see what happens there. So if I test, so if I say, okay, so 1/2 is sort of perfectly in between 0 and 1. Maybe next you say, if you have the time, say, okay, let's see what happens when I test fractions on the extreme end. So one's closer to 0 and one's closer to 1. So maybe I'll test 9 over 10 and 1 over 10. So in this case, 1 over x is going to be just the reciprocal, which is 10 over 9. And 2x will be 18 over 10. And x squared will be 81 over 100. And so in this case, here is where we get a different result, because this is going to be, this is our smallest. So we get x squared is the smallest again, but then we have 1 over x in second place. And 2x is the biggest. And so this means 2 is also possible. Now, we haven't come up with anything for 3 yet, so either you got to say you can't select it as an option. So if we were to stop here, we would have to select D, and D, I believe, is the right answer. And if we chose 1/10, what would happen there? Let's just see. So this would be 10. This would be 1/5. This would be 1 over 100. So here we would have x squared, 2x, and 1 over x. So we would get the same result that we got over here. So if you only tested one of these, if you only tested the 1/10 and not the 9/10, you went down instead of up, you would never see this was an answer choice. And so if you're testing numbers, you really got to test probably 4 or 5. And 2 or 3 of those need to be fractions to really get the right answer here. So is there a more algebraic way of doing this? And I can't say that I would necessarily see this during my actual test, but the best answer I could come up with, so the answer is D. There's no way you'll never be able to get this option, and so it's sort of you can eliminate it just by virtue of the fact you couldn't prove it could be true. The best algebraic way I've thought of this is if you break up your inequalities into 2 individual inequalities. So statement 1 can be thought of as saying x squared has to be less than 2x, and 2x has to be less than 1 over x. So is it possible for these 2 things to be true? And then we can solve for x here. So here, if I divide, remember, x has to be positive, so we don't got to worry about flipping our signs or anything. So here, if I divide each side by x, I get, okay, so x has got to be less than 2. And then here, if I multiply each side by x, I get 2x squared is less than 1. Then I can divide each side by 2. I get x squared is less than 1/2. And then I get, if I take the square root, I get x is less than the square root of 1/2. And so this could be true, this statement, if x is less than 2 and x is less than the square root of 1/2. But that's really just saying this will be true when x is less than the square root of 1/2. And so that means this is possible as long as this is true. So that means statement 1 is good. And so the only way we can say a statement cannot be true is if our 2 inequalities here contradict each other. So these do not contradict each other. But it's really, it's sort of like the one here on the right is just the more limiting one. So that's the only one that matters. So if we do the same thing with statement 2, so can both x squared be less than 1 over x and 1 over x be less than 2x? So when will this be true? So if we multiply each side by x, we get x cubed is less than 1. And so then based on that, remember, x has to be positive, so we can just take the cube root of each side, and we get x has just got to be less than 1, and really greater than 0, because it's got to be positive. And then here, we get, if we multiply each side by x, 1 is less than 2x squared, and so this is the same. So x is got to be greater than the square root of 1/2. So is it possible for x to be both between 0 and 1 and greater than the square root of 1/2? Well, that should be that's possible, because the square root of 1/2 is a fraction between 0 and 1. So like this one here, since they don't contradict each other, it is possible to have this case, and therefore it is possible to have this order. And then statement 3 says, so we want to see, is it possible for 2x to be less than x squared and x squared to be less than 1 over x? So in this case, we can divide each side by x, and this will be true when x is greater than 2. And this will be true. So if we multiply each side by x, we get x cubed is less than 1. And then take the cube root of each side, and we get, so this will be true when x is less than 1. So now what are we saying? So this whole thing will only be true if x is greater than 2 and x is less than 1, but that is not possible. So here are 2 individual inequalities. They do contradict each other, and that is why this third guy is not possible, and only 1 and 2 are. So that is sort of the best proof I can think of. But no matter how you do it, if you do it this way or the testing numbers way, it's probably going to take a long time. There are a lot of ways you can screw it up. There's a lot of room for math errors. So I would not hesitate to, if I can eliminate some of the answer choices, maybe that is the best bet here. And at least certainly the best bet to take an educated guess within 2 minutes as opposed to getting the definitive answer, but in 5 minutes. Very, very hard question. And remember, the answer was, in case you forgot, it was D.